There's a machine that's basically the beating heart of our civilization, just humming along silently behind the scenes, and you've almost certainly never given it a second thought. But I guarantee you, without it, the modern world would just grind to a halt. We're talking about the alternator.
I mean, really think about the scale of that for a second. It's not just your one little light bulb. It's this entire invisible network that powers everything from your phone to our biggest factories. And the answer to how that's even possible? Well, it lies with this unsung hero. So what is this thing exactly? At its core, an alternator is a special kind of generator. Its job is to take mechanical energy, the motion from a spinning turbine that's being pushed by water or steam or wind, and transform it into the alternating current, or AC, that flows through all of our power lines. But how does it actually do that? I mean, what's the trick? Well, it's not magic, but it's pretty darn close. It's all thanks to this fundamental principle of electromagnetism, a discovery from the 19th century that literally powers our world today.
Okay, I know these diagrams look a little technical, but they show a really, really simple idea. Over on the left, you see that spinning magnet. That's what we call the rotor. As it spins, its magnetic field is constantly sweeping across those stationary wires wrapped around it. And the diagram on the right, that's just a close-up. The moving magnetic field literally shoves the electrons in the wire, getting them to move. And moving electrons, that's an electric current. That's the whole secret right there.
It really just boils down to this beautifully simple equation. If you've got motion and you've got magnetism, you can make electricity. This is the bedrock, the absolute foundation of pretty much all large-scale power generation on the entire planet. All right, so we get the principle. Now let's crack this thing open and look inside the machine itself. Because modern alternators have this incredibly clever kind of inside-out design that makes them so powerful and efficient. So the first designs, they work the way you'd probably guess. They spun the big, heavy coils of wire, that's the armature, inside a stationary magnetic field. But then engineers had this brilliant idea. Wait a minute, why not flip that around? So in modern alternators, the much lighter electromagnet, the field, is the part that spins, while the really heavy, high-power coils just stay put. And let me tell you, this design is a total game changer for so many reasons. Because the high-power wires are stationary, it's way easier to insulate them for ridiculously high voltages. We're talking up to 33,000 volts. Plus, you can connect them directly to the power grid without needing these complex, clunky parts like slip rings that wear out. And maybe best of all, since the part that's spinning is lighter, you can spin it a whole lot faster, which means more power, more efficiently. It just wins on every level. So let's look at the first key piece, the rotor. This right here is our spinning electromagnet. All we do is feed it a little bit of DC power to create a really strong magnetic field. After that, its only job is to spin, 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 and create that moving magnetism we need. And wrapped around the rotor, we have this, the stator. And just like its name sounds, it's stationary. This is the armature, a massive bundle of wire coils where the actual usable high-power electricity gets created when the rotor's magnetic field sweeps past it. So you put them together and bam, you've got the heart of the alternator. The rotor spins inside the stator. Its magnetic field cuts across those stationary wires over and over again, and that induces a powerful alternating current. It's simple, it's elegant, and it is unbelievably effective. Now, generating power is one thing. That's a huge achievement. But connecting that power to a vast electrical grid, well, that is a whole different ballgame. It requires a level of precision that is just astonishing. Think about it. No single power plant can handle all our energy needs. The grid is this massive, interconnected web of hundreds of alternators all working together in parallel. But here's the catch. You can't just flip a switch and connect a new generator to that network. The results would be, well, let's just say catastrophic. Before any alternator can join the party, it has to be perfectly synchronized. And that means 3 conditions have to be met exactly. First, its voltage has to match the grid's voltage, or else you get a massive power surge. Second, its frequency, the speed of the AC cycle, has to be identical, so it's pushing and pulling in perfect time with everybody else. And third, its phase sequence has to be the same, making sure the flow of power is rotating in the same direction. This diagram here, this shows the moment of truth. You've got generator 1, or G1, already running and powering the grid. And now you need to bring generator 2 online. That switch that connects them, it can only be closed when they are in perfect, flawless step. If you get that timing wrong by even a fraction of a second, you're risking huge power surges and destroying millions of dollars of equipment. No pressure.
Honestly, the best way to think of it is like the power grid is a continent-sized orchestra. Every single alternator has to play in the exact same key. That's the voltage. They have to play at the exact same tempo. That's the frequency. And they have to be in perfect rhythmic time. That's the phase. It's this beautiful, incredibly high-stakes dance of precision engineering.
So let's pull back and bring it all together. Why have we spent this much time talking about a spinning piece of machinery? Because without it, the world as we know it, it just couldn't exist. Plain and simple.
This quote from Electrical A to Z really sums it up perfectly. Now, it specifically mentions vehicles, where small alternators have an extra part to create DC power to charge the car battery. But the principle is universal. The alternator's ability to reliably pump out massive amounts of controlled electrical energy is absolutely vital for the safety and the long life of any electrical system, whether it's a tiny one in your car or the entire continental grid. When you get right down to it, the alternator is the true unsung hero of our time. It's the core technology that reliably keeps our lights on, powers our industries, and guarantees the stability of our entire way of life. It has been the invisible engine of progress for more than 100 years.
And that just leaves us with this one final kind of wild thought. The basic principles of this machine were figured out back in the 1800s. And yet here we are, and it's still the absolute backbone of our super advanced 21st century world. So as we look to the future, the really big question is, what comes next? What invention is